Hello and happy Tuesday, everyone. So today, here's what you're going to do while I'm away. First thing you're going to do, you should have pages 9 through 11 done. If you do not, that is the first thing you want to do, and you want to do it quickly, because all of these things I'm going to go through need to be done by today. So finish 9 through 11 if you haven't. The water molecules and ethane and ethanol are still available. If you have finished page 9 through 11, what you're going to focus on is page 12. Page 12 is going to review everything you should have learned on page 9 through 11. So what you should have seen on 9 through 11 is that oxygen is very polar, which means that oxygen has a slight, water is very polar. Because of this, oxygen has a slight negative charge, which means it's attracted to positive things, because positives attract. And hydrogen has a slight positive charge, which means it's attracted to negative things, because opposites attract. That's going to be really important as we go on in this unit, so make sure you understand that, understand why water interacts with things the way it does, and answer these questions on this page. Again, if you have questions, go ahead and email me. I will be on a plane today, but I will email back as soon as I am able and no longer in there. Okay, when you have 9 through 12 done, there is a key for it. So when you have that page 12 done, go ahead and check the key, and then you're going to go get this activity, boiling point data and graph from the sub. She will have that, or he, I don't know. They will have that paper for you. And that paper, put that to the side, is going to look like this. So this gives you background. Basically, this activity, we're going to talk about boiling point. We're going to look at different Lewis structures, and we're going to graph boiling point. When I get back, we're going to talk about why different things have the boiling points they do. What I want you to look at now, though, is these things you need to take. You'll need a periodic table. You should all have one, but if you don't, you all know where they are. They're against the wall on the counter, and I will print more. You'll need colored pencils. Okay, if you don't know where the colored pencils are, here's where they are. So if you look at the cart in the front of the room, the two green drawers, they are the second two drawers. That's where the colored pencils are. So you will need a set of colored pencils for this activity. You will also need, you don't need a ruler, you can draw straight lines. If you really want them straight, use an extra paper. Electronegativity chart, which I included on the back, and a regular pencil. So we're going to get started here. In this activity, you have this page. I'm going to walk you through how to do this page with one example. You'll need to do this for every single thing on this page. So here's what this page is going to look like. So first we have CH4. You see that? So CH4 here. We need to draw the Vesper shape. So CH4, C has 4 valence electrons, H has 1 times 4 is 4, so we have 8 electrons total. We're drawing the Vesper shape, so we're drawing the shape, not just the Lewis structure. So remember, you might want to get your Vesper sheet out. That is totally fine. Hopefully you have one. If not, hopefully your partner has one. You are able to work with your partner on this. But with CH4, you have one H going away, one H coming towards you, and 2 flat H's. Next, it asks for the polarity of the CH bond. Well, if you look at your electronegativity sheet, the polarity is 2.55 for C, and the electronegativity for H is 2.20. If we subtract those, we get 0.35. Okay, remember, if the polarity is between 0 and 0.4, it is nonpolar for electronegativity. Nonpolar covalent means it shares equally, so there's no charge. If it's between 0.4 and 1.7, it is polar, meaning it doesn't share equally. And because it doesn't share equally, the one with the bigger number is going to have more electrons, making it more negative. And finally, 1.7 and above is going to be ionic, meaning one completely takes the electrons, leaving the other without them. Okay, So it's 0.35, so this bond is going to be nonpolar. If the bond is nonpolar, the molecule cannot be polar, so we're going to circle no. Okay, you're going to do that right there for each of these molecules in each of these boxes. You'll see for some of them the polarity is already done for you, so you'll just need to draw the shape. So when you get done with that, you're going to move on to this page. When you look at this page, you will see we have periods on the X. Remember, period is a horizontal row on the periodic table. And boiling point on the Y. So what you're going to do is you're going to take these boiling point values that are right here, and you're going to graph them. So how you're going to do that, let's take a look first at CH4. CH4 has a boiling point of negative 161 degrees Celsius, and it is in period 2. Okay, so all of these boxes right here in this first row are going to be in period 2. This also tells you the group names. Well, the group names aren't over here, so why do you have the group names? Just because I know half of you will not read the instructions, be honest. The group names are for this reason. So you needed color pencils, right? Each one in this group, you are going to use one color for each of these. So your line will be colored. So let's use orange for group 14. I'm going to put an orange right there. Okay, so CH4 is 161, and it's in period 2. So I'm going to go to period 2. I'm going to go down to negative 161 and put a dot and label it CH4. It's really funky to be writing through this camera. Hold on. Okay, that's not much better. But that dot is CH4. Okay, let's go to the next one in group 14. It's in period 3. See that? It's SiH4, and it's negative 111. So we're going to come to period 3 to negative 111, which would be halfway between 100 and 120. I'm going to label it SiH4. Okay, let's find the next one in group 14. GeH4, negative 88 degrees Celsius, period 4. So we're going to come up to period 4, negative 88. And we're going to label it GeH4. Period 5, SnH4, negative 52. So 50 would be between 40 and 60. SnH4. And last but not least, same group, PbH4, negative 13, period 6. So period 6, all the way down. So we're going to do it about right there. PbH4. Okay, now that you've got all of the ones in the same group on the table, you are going to draw a line between them. This is where you can use a ruler if you have one, or you can use the side of a paper. Obviously, I'm doing this one-handed, so it's not going to be very great. So draw a line connecting all of the groups. Y'all, this is awful. Okay, so we have a line connecting all of the groups. Then you're going to do the same thing with group 15. Find it, find the period it's in, the boiling point, and graph it in a different color. Then do 16, then do 17. So in total, on this page, you should have 4 different lines with 4 different colors. Okay, if you have questions, please email me, let me know. My email is on the board. I will be on a plane today, but I will email back as soon as I can. You do need to get this graph done today. Next time we're going to talk about the importance of that graph and why we had you do it. Again, any questions, please email me. And make sure you put everything away nicely, leave my floor nice, and I will see you on Thursday, guys.